Okay, so just one more go at the synthetic division. So say you have this polynomial here, and somebody wants you to factor it. Okay, so um, you don't really know how to factor this, but you can make a guess of what its factors might be. Okay, so the end number here is a 6. So you think of possible factors of 6. So we have x plus 1, because 1 will go into a 6. We have x minus 1. We have x plus 2, because long division, we would write this number out here, and then we would write our polynomial here. And if you imagine writing this out for every single one of these, that would be a lot of space, it would be a lot of work, it would be very time consuming. So this is something that synthetic division is very good at shortcutting. So what we do is we write our polynomial that we were dividing into in our shorthand notation. So we write 1 to divide into, and then we pick one of these factors to work with. Okay, I made this up, so I happen to know that this, and this are its factors. So I want to start with one that's not a factor, so we can just have an example of what that looks like, and so that we can end up dividing more than one thing. So say my first guess is I'm going to divide in x plus 2. Now remember, we changed the sign, so we write minus 2 to divide in x plus 2. Okay, and then we carry out the synthetic division. So step 1, let's bring this number down. Okay, step 2 is multiply. So minus 2 times 1 is minus 2, and then step 3 is add. So we add 6 and minus 2, and we get 4. And if we like, I think it's helpful to have a line right here. Okay, so bring this down, multiply, add. Let's show the 0. This number goes up here. Okay, then we repeat. Multiply, minus 2 times 4 is minus 8, and add. Right here, so since we got a remainder that's not 0, this is not a factor. So this is our remainder, which is not 0. Let's just put equal not 0. So that means this is not a factor, not a factor. Okay, that's okay. We'll talk a bit later how this number is actually still useful with something called the remainder theorem. This is actually your y value when x equals minus 2. So that can be useful if you're making a graph. But right now we're just focusing on the synthetic division. So we tried that factor. Didn't work. Should we try another one that didn't work? Nah, let's just go to one that works. Okay, so I happen to know this works, but you wouldn't know this. So we tried this, we're unsuccessful, so we need to move on to another one of our possibilities. So we write the next possibility right here. So we were trying x plus 6, so we write a minus 6. And we just follow exactly the same steps as before. We don't really need to rewrite this. I mean, you can just rewrite everything all over again, but you can just keep this at the top and maybe make a box around it or something, so it's easy to refer back to. Okay, and just bring your steps here. So it would look like step 1, bring the first number down. So we would bring our 1 all the way down to here. And then draw a line. This is going to be our answer. And step 2 is multiply. So minus 6 times 1 is apply. Minus 6 times minus 1 is 6. And then the last thing we're going to do is add. So minus 6 and 6 is 0. Awesome. That's a remainder of 0. So let's go over here and say remainder equals 0. So this is a factor. Hooray. Okay, so it looks insanely messy here, but if you practice a little bit, you might find that you like this, only writing the original polynomial once and then just sort of leaping back. Your eye does have to cross over here, so you are more likely to make a mistake than rewriting this part each time and then just dealing with the 3 columns. Okay, so let's see, what have we learned? This is our remainder. If it's not 0, then the thing we're dividing in was not a factor. If it is 0, then this was a factor. And remember that once we found a factor, in order to find the other factors, we don't always want to keep dividing back into the original. I mean, we could now try dividing this in, this in, this in, this in, this in. Oh, look, and then we would get it, right? Because I have to know what that is. But better is to realize that this is one of my factors, x plus 6. So I now know that this polynomial equals x plus 6. Now, every time you take out, this is called a linear factor because it just has an x to the power 1. Every time we take that out, we'll be left with a polynomial that is 1 less than the degree of the original. So, oh yeah, and this represents x squared, no x's, and a minus 1, like that. So see, the third order became a second order. As soon as I'm down to a second order, I can just factor that using my old factoring skills. So I will go x plus 1 times x minus 1, because I know that makes x squared minus 1. Now, if this polynomial right here was, say this original one had been a fourth order, then this would be a third order, and I wouldn't just be able to quickly do that in my head, but I could just divide into it using the synthetic division. So this would become my polynomial to do the synthetic division on. Maybe we'll give an example in the next part.